purposes. And I'm struggling with ESA and all the other instruments to get those images down. And I know Mars very well. I'm working on this mission since 2005. It's almost the entire 20 years now. And I became part of this dear Mars family.
We had a question from Jacqueline Rosales, who's invited young students to watch. So hello to all of her students and any other students who are watching. And she said that she'd like a really kid-friendly understanding of how signals are plucked out of the air and translated into visual and readable data. And I think that's a good one, not just for kids, but I'd quite like it myself too. Jorge, maybe you could take this. How are signals taken from the air and translated into these images that we can see visually?
Yes, that's a long process, because what we get from Mars is basically a bunch of ones and zeros. So there are a lot of interfaces in the middle, because I, as a scientist who works in data processing, basically get some data from the engineers, but engineers have they have other systems and they see a lot of other things, and they filter. Whoa, we have a corrupted image. This is because
it's art.
Yeah, this is a bit like art. The thing is that because we have this bad weather, the program that we have here processing, now we are receiving, I think, I think that it's going to solve in a few seconds probably, but basically what we have here is that because we have bad weather, we load some packets. I will speak about this in a moment, and because of that, the program was not able to solve the real image, and it basically puts, here we have a good one. Yeah. I think that it's going better. Actually, Simon was telling me that the weather is going better. Basically, in the case of BMC, we have 76 packets. These packets are the kind of the way in which engineers put the information in a way that the scientists can really access to the data. And with these 76 packets, each packet includes more or less like 4 kilobytes of information, and from that, basically, each byte corresponds in the case of BMC to a pixel of the image, and then we create the BMC image from those packets. Now, because in the case of BMC, it was not designed to be a science camera, so there is a lot of processing to be able to obtain beautiful images like this. And this involves a lot of things. One of the things is the thing of the color. It's very common to ask, what is the real color of Mars? And in fact, in these images, they don't show the same colors as we would see with our eyes. Actually, color is a very complex topic related to the way in our eyes work. But basically, in the case of BMC, the color is more or less with the same system as with mobile phones. They have something called Bayer pattern, which is that each pixel has different colors, and then we make color images from that. But it's not like it's not the ideal science color image. And we also remove the noise, and we do different kind of processing to try to obtain an image that looks like this. From the ones and zeros that we get from Mars, and that engineers process a bit for us to help with that, because they really get actually away from the antenna that I will not understand, and they help us with that, of course.
But actually, I mean, for Daniela, it's even more complicated with your camera, because you don't just have a flat image; you actually take pictures in 3D.
Yeah, we do not take them in 3D. We take them in 9 different channels, 4 color channels and 5 panchromatic channels. And we use basically 4 of those 5 panchromatic channels, which are taken at different viewing angles to produce a digital elevation model. The principle is just as how we do this with our eyes. So we have 2 eyes of 2 different positions, and we look at the world with 2 different viewing angles, and our brain creates a three-dimensional image of this. And we do pretty much the same, just a little more sophisticated. And so we get our three-dimensional images. So, but this is a long way of image processing, and the raw images are, of course, they look like a photograph. But very long photograph. We don't take our images like a framing camera, so at one shot you get the entire area. What we do is we have a scanner, a line scanner. We scan the surface in thousands of lines and stitch them together in a very long image stripe, which we also call an orbit.
Okay. The questions are coming in very fast, and I think we're taking a long time to answer these questions. So we can try giving some short answers to questions. There's some fascinating questions in there. One question I just saw is, what is the power broadcast from the spacecraft, and what is the power received at Earth? Simon, have you got? I think it's tens of watts at the spacecraft.
I think the transmitter on the spacecraft uses 120 watts of power.
And then it transmits about like 5 or 10 watts of transmitted power. So if you imagine a 10-watt light bulb or something like this, that is about how much power we are sending from Mars. So it's phenomenal to think that you can observe something consuming as much energy as a light bulb from 300 million kilometers away. So that's how much is broadcast, and then by the time it's 300 million kilometers away, we are sensitive. I think I saw a plot today of zetawatts, which is a millionth of a thousandth of a watt. It's a tiny amount, and that's just a testament to how sensitive the receivers are in these very big dishes. So that's the power question. Just jumping randomly between these questions, there was a question about the cost of the mission. So this is something we get quite a lot. Mars Express was built for, I think the project cost was 150 million euros. In fact, that's not correct, because it's 150 million écus, the European currency unit, which is a precursor of a euro. Again, a reminder of how long ago it was that this was agreed and built. So if you just think the number 150 million sounds like a lot, but that is like 50 euro cents per person in Europe. So what can you buy for 50 euro cents? You may be thinking of a candy bar, and now you can think also of a Mars spacecraft. So if everyone contributes 50 euro cents, you can buy a Mars spacecraft.
I have a question that's kind of related to the value, but why does it matter that we understand about Mars? We had some questions asking about if we're talking about Mars weather or Earth weather that's getting in the way of the signals, but how does Mars help us on Earth? Does it help us, or is it just kind of escapism, interesting? What's the point?
So there are lots of different there are lots of different answers to this question, and different answers work for different people. Some people like to explore Mars because it's there. It's like the answer about Everest. It's the human spirit to wonder what is on the frontiers, what is out there, what is next door. Some people think of Mars as a future place to live or explore. I think in the short term, don't sell your house, because it's very difficult. We can't breathe there. But the European Space Agency, like many space agencies, does intend to send people there on exploratory missions. If you are not moved at all by the exploratory instinct of Mars, you can also think that a lot of space exploration is useful for Earth. We have weather satellites observing Earth. We have communication satellites. We have GPS steering our vehicles. And the money spent on planetary exploration is at least an order of magnitude, at least 10 times less than what is spent on Earth orbiting satellites, which are used in our daily lives. And the planetary exploration does help develop technologies which are for our benefit on Earth. Daniela, did you want to add something?
Yeah, there's one neat thing about Mars I wanna add to the list of reasons why we do this all. The thing is that Mars and Earth are almost the same age, and they experience the same conditions in our solar system at the same time. But on Earth, everything, all the surfaces are relatively young, because we have plate tectonics that eat the surface and renew it again. We have a lot of weather and erosion that vanishes all the traces of the earlier terrestrial history. But on Mars, you have, so to say, a picture of our solar system that goes back to 4.2 billion years, so almost short after the formation of the planets. So if you study Mars, you can learn about the history of the Earth, about the history of the entire solar system, of all the terrestrial planets. You can analyze extremely old rocks, and you can learn a lot with what we call a planetary analogy, vergleichende, comparative planetary exploration. And this is a really neat thing.
They've said no audio, but maybe keep going. Sorry.
I'm almost done. I can also, I can add, as a geologist, the other advantages of Mars. It's pretty easy to, relatively easy to reach compared to other planets. Try to fly to Mercury and you will understand what I mean. But the geologic processes that occurred on Mars are relatively similar to those that occur on Earth. So we have tectonism, we have volcanism, we have the action of wind, we have the action of water. We had the action of water on Mars, actually, but we can see when this water has been there, how much water has been there. We can deduce old climatic conditions 3.7 billion years ago and see whether Mars might have been habitable in this time. And the interesting thing is that we found out that Mars was indeed habitable at 3.6 billion years ago at certain places. And this is exactly the same time when life, the first microbial life, occurred on Earth. And isn't that a question? Isn't that interesting? And now we move on in answering this question, if this is related to each other or not.
Well, Daniela was responding as a geologist, and I would like to respond a bit as a climatologist. In the sense, I am really excited about studying Mars. I grew up as a kid who dreamed of the space, and being right now here is like a dream, like a life dream for me. But as a climatologist, I think that studying Mars and studying the atmospheres of other planets are also a very good way to learn about our own planet. I think that in a way, it's like we can see ourselves in a mirror, and that way you can learn about ourselves. But when we talk to other people and when we learn about other people, we understand better or in a different way ourselves. And I think that with Mars and the other planets, it's kind of the same. When we study other planets, we can understand more about our planet. But also I have to say that we need to be realistic, and we need also to remember that we are now in a huge crisis, in a climate crisis, and we need to do much more than we are doing. In fact, when we look to the Earth from space, we usually think a lot on how beautiful is our planet. There is this pale blue dot image that was taken by the Voyager spacecraft, and I would like to say save the pale blue dot. This is one of the things that we could say when we look back to the Earth from space. Because saving the pale blue dot, saving the core of the Earth, is not really saving the Earth. The Earth is really resistant. It's about saving ourselves, and this is what we need to think. We need to really act more for this, and this is what I can say as a climatologist.
I just wanted to say that we've got about 7 minutes left now, and Mars is gradually disappearing off of the screen, as people will be noticing. And a few people have asked kind of where it's going and why it's disappearing. So I think it's maybe worth touching on that, just so to get back to what's being shown, and then carry on again with this conversation, which is so interesting. But yes, Mars is gradually disappearing off screen. Why, and can we see it again?
It's disappearing off screen simply because Mars Express is moving past it. So it's currently heading effectively, as we said earlier on, behind it. You can see the elliptical orbit that we're in, and it's as a result of this, it's moving out of the field of view of the camera. We will see it again because it would, if we were to keep this live stream going for another 7 or 8 hours, it would come back round again. Mm-hmm. So we just had a question in terms of whether it's possible to recover the images that were not shown due to bad weather. In principle, yes. It is something that we do have to do from time to time because, as I said, we do have data outages due to weather or issues with the spacecraft or issues with the ground segment. And it's typically involved with, if it was just a problem with getting the data actually to the Mission Control Center here in Darmstadt, and it was actually received at the ground station, then actually it would be quite easy because we can actually connect. It's all recorded at the ground station, and we can simply re-request it. To actually get the data back from the spacecraft, we'll have to send a series of commands to it to tell it to copy the data that it's recorded to a different part of its onboard memory, and then we could redump that later.
And are you going to?
That would depend a little bit because we've actually to actually do this live stream, because actually the data downlink on Mars Express is often extremely sought after by the instrument team. So they're producing science and they want their data down on Earth, and so we have to very carefully schedule all of the data dumps to make sure that we get everything down and nothing's left on board, because at the end of the day, if we can't get it back to Earth, there's no point recording it. And so actually for this live stream to work, we've actually had to turn off an hour's worth of data dumps, including some from HRSC. I'm sorry, Daniela. But rest assured, our mission planning team are actually working in the other room at the moment, because they were actually putting commands up that will go up next week that will actually then dump the data that would have come down in this pass were we not doing the stream.
So in case you missed the introduction earlier, we are talking to you live from the European Space Operations Center, and this is the control room. This is where they send control commands to the spacecraft and where they receive the data coming back to it. There have been some questions about the graphic on the right-hand side, people asking about whether there's an ocean on Mars. So the colors on that simply represent the elevation. So red areas are high, blue areas are low. You might immediately see that the northern hemisphere has lots of low terrains. If there was once a large ocean on Mars, then people think this would have been a sort of sea-covered ocean. There's also a massive impact crater in the south called the Hellas Basin. We think this may have formed when a late bombardment, a late object came and smashed and made a giant impact crater. So it's quite dramatic topography. If you look closely, you can also see some high points, which are very tall volcanoes, the tallest volcanoes in the solar system. About why the image is disappearing. Again, it is an orbit, so we go round and round and round. We go round every just under 8 hours is the orbital period, and so that means that after 7 hours we will be back. By now, Mars Express has completed 24,000 orbits of Mars, so we do have confidence that it will come around again. Because it's done so many times, and not only do our equations say this, but our experience says this as well. So just again a reminder, why are we here today? Why are we doing this? So we are celebrating the 20th anniversary of the launch of Mars Express, which was at 7:45 p.m. Central European time, which is coming up in about an hour or so. But 20 years ago, and the mission was originally built and financed for a mission lifetime at Mars of 1 Mars year. It has now achieved 10 Mars years at Mars. It has now outlived its expected lifetime by a factor of 10, which is just a remarkable testament to everyone who built the mission, who designed the mission, and has operated it. And as one of the scientists who had an instrument which went up originally, this is just amazing to see, and it's wonderful to be here today. Over to you, Rosa.
We just have 1 minute left and Mars is disappearing. But if you want to see more images like this, we actually have a less live, but liver than most images of Mars. And that's if you go to the Mars webcam on social media. It used to be on Twitter. You can still follow at ESA Mars webcam on Twitter, but it's not updating anymore. So we have moved to Mastodon. If anyone is modern, they can go to ESA Mars webcam at mastodon.social, and the images that are currently coming down will actually go straight to Mastodon, not quite as quickly, because what we're doing now is
difficult and special, and the team have spent ages preparing for this. So big thank you to them and to everyone that works on Mars Express and all the scientists. You can also go to Flickr. Slightly less modern than Mastodon, but still cool. You can get images on Flickr from Mars Express, and you can go to our website, as always, ESA.int, and more news from Mission Control at ESA Operations on Twitter. We're all over the place. And our hour is up and Mars is disappearing. And thanks to everyone, to Daniela, Jorge, Colin, and Simon. And also you can have a look at the incredible HRSC mosaic image of Mars that also came out for the 20th birthday of Mars Express. And thanks to everyone who joined. We've been amazed at how many people have been watching, and it's been very special. It's really rare to get something like this so live. So thank you, everyone.
Yeah. I'll
It was
resist the
fun,
temptation
thank you.
to sing happy birthday tomorrow. But you can all sing it yourselves at home.
Sing happy